let's learn about the exact sequence. So here we define an exact sequence. So a sequence of R modules MRs and R homomorphism FRIs is said to be exact at a module OMR if image of FR minus 1 is equals to kernel of FR. That means it is restricted to this condition. So when we say a sequence is exact, because if image of the previous homomorphism at MR is equal to the kernel of successive homomorphism, that it would be exact at MR. So when we say a sequence is exact, if the sequence is exact at every module, that means this condition satisfied at every module, then the sequence is called exact sequence. As you see, let's understand this with these two sequences, first and second. Here first sequence is from 0 module to module M and to module N. This sequence is exact at M. And second sequence from M module to N module and N module to 0 module is also exact, but it is exact at N. If the sequence first is exact at M, then image from 0 to M is equal to kernel of F. Now we have to show that here F is injective. Okay, so let's see how we proceed. So the map from 0 to M sends only 0 to 0. So image from 0 to M contains only a single element, that is 0. So kernel of F is equals to 0. So we know an important result that a homomorphism has 0 kernel if and only if it is injective. So here kernel of F is equals to 0. So F is injective. Now see the second sequence. Now if the second sequence is exact at N, that means image of F is equals to kernel of N to 0. So the map N to 0 sends every element of N to 0. So kernel of N to 0 is N. Hence image of F is equals to N, because kernel contains all the elements of N and M also has image equals to N. Hence image of F is equals to N. This implies that image equals to the whole codomain, which means F is surjective. If you want to learn these two results, you can also remember that from this thing. If 0 is given on the left side, then F is injective, and if 0 is given on the right side, then F is surjective. This is only a method to remember these things. So we understand about the exact sequence. Thank you.